Watch this video about the normal distribution. You will need the laminated table that I gave you in class to answer the questions on the handout. The first question deals with math and verbal scores for females taking the SAT. We are asked to find the percentage of females who do not satisfy the requirement. In order for them not to satisfy the requirement, they must have a score less than 1,100. So we are trying to find the probability that X is less than 1,100. First, we must convert the score to a standard score, a z-score, using our formula. Z equals X minus mu divided by sigma. Z equals 1100 minus 998 divided by 202. Our z-score is 0.50. So we're actually trying to find the probability that z is less than 0.50. Remember, anytime you have a less than problem, you look up the z-score in the table to get the corresponding probability. In this case, the probability is 0.6915. And then we're asked to change it to a percentage. To do this, we move the decimal 2 places to the right to end up with 69.15%. The next question deals with annual rainfall in a region. We're asked to find the probability that there will be floods. For flooding to occur, the rainfall exceeds 57 inches. We are looking for the probability that X is greater than 57. First, convert 57 to a z-score using our formula. Z equals 57 minus 50 divided by 4. The z-score is 1.75. So we're looking for the probability that z is greater than 1.75. Remember, with a greater than problem, you look up the z-score. The z-score of 1.75 produces an area of 0.9599, and now we must subtract. 1 minus 0.9599 gives us an area of 0.0401. The next question is an in-between question. We have to come up with the probability that the blood pressure is between 120 and 140. We must convert both scores to z-scores. Converting 120 to a z-score, we have 120 minus 138 divided by 10. That equals a z-score of negative 1.8. Next, converting a z-score of converting a value of 140 to a z-score, 140 minus 138 divided by 10 is 0.2. So we're looking for the probability that our z-score is between negative 1.8 and 0.2. Look up both z-scores in the table to get their probabilities. The probability that the z-score is 0.2 is 0.5793. The probability that the z-score is negative 1.8 is 0.0359, and now we must subtract to get an answer of 0.5434. The next question deals with scores for men on the verbal portion of the SAT. First of all, we want to know the probability that the score is at least 590. That means the probability that X is greater than or equal to 590. First of all, we convert 590 to a z-score. Using our formula, we have z equals 590 minus 509 divided by 112 gives a z-score of 0.72. So we're actually trying to find the probability that z is greater than or equal to 0.72. With a greater than problem, you look up your z-score. If you look up a z-score of 0.72, the area is 0.7642, and then you have to subtract. 1 minus 0.7642 is 0.2358. The next question deals with the mean weight of food packets. The first question, we want to find the probability that we have more than 510 pounds. That's the probability that X is greater than 510. Since it's a greater than problem, we first of all convert 510 to a standard score using our formula. Using our formula, our z-score ends up being 2. We then have the probability that z is greater than 2. We look up our z-score of 2, which gives a probability of 0.9772. Then we have to subtract 1 minus that probability to give us a final answer of 0.0228. The next part to this question is the probability that it's less than 498 pounds. So that's the probability that X is less than 498. First, convert to a z-score. So our z-score is 498 minus 500 divided by 5. Our z-score is negative 0.4. So we're actually trying to find the probability that z is less than negative 0.4. With the less than problem, you look up the z-score. When we look up the z-score, our probability is 0.3446. That is our answer. The next question is find the probability that the weight is between 491 and 498 pounds. This is an in-between problem, so we have the probability that X is between 491 and 498. Convert both scores, or both weights, to z-scores. 491 will convert to a z-score of negative 1.8. 491 will convert to a z-score of negative 0.4. So we have the probability that negative 1.8 is less than z is less than negative 0.4. Look up both z-scores in the table, get their corresponding probabilities, then subtract. We end up with a final answer of 0.3087. Next, we have to find the probability that the grocery store is overstocked. To be overstocked, we have more than 5,300 pounds of meat. So we're looking for the probability that X is greater than 5,300. First, convert 5,300 to a standard score using our formula. Using the formula, our z-score is 1. So we're looking for the probability that z is 1. Since this is a greater than problem, you find your area or probability that corresponds to the z-score. That probability is 0.8413. And now you have to subtract 1 minus that probability. Your final answer is 0.1587.